In section 4.6, we are reviewing the graphs of linear inequalities. First, we'll start with horizontal and vertical lines. X, and with no Y, remember this is a VUX scenario. That's a vertical line. So we need a vertical line at -2. But before we just draw that in, we need to think about the symbol. X is going to be the shaded stuff. The shaded stuff needs to be bigger than -2, but notice that there's no equals line on that symbol. So are we including -2 in the shaded stuff or not including? Not including, which means this line needs to be dashed to indicate that this is the boundary line of the shading, but the solutions do not include the values on this line. A solid line means the solutions on the line are part of the solution. A dashed line means that the stuff on that line is not a part of the solution. Then I want you to think about what the symbol actually means. X is the shaded stuff. The shaded stuff needs to be bigger than -2. Where on this graph are the X values larger than -2? To the right, towards the positive side. So you would shade this side of the graph. And you can shade it kind of like that. You can actually like physically shade it in. If you're a highlighter person, you could highlight. I know highlighter doesn't work very well. Oh, that's just a yellow pen. That's not a highlighter. Whoopsies. I just know my highlighter on here doesn't work very well. See how it's like lagging? Eventually, it might pop in there. Or it'll turn to the next slide without me realizing it. Okay. The next one, y is less than or equal to 4. This time we are dealing with a HOI, a horizontal line at 4. So find 4, find where that horizontal line would be, but before you actually draw it in, think about, is the line included in the solution set or not? Yes, because there's an equals line less than or equal to, that means the line is also included in the solutions. It says y is less than or equal to 4. Where on this graph are the y values smaller than 4? Below, so we would shade down here. Okay, we're going to play a quick little game. It's not really a game, but I'm just going to call it a game. I am going to put a couple of points on the graph, and I want you to tell me if the point is a solution to the inequality or not. So let's call this one point A. Is point A a solution to inequality? Yes. Is B a solution to that inequality? No. Is C a solution to the inequality? Yes, because it's on the solid line. On the previous inequality, if I put a dot here and call that point D, is D a solution to that first inequality? Why not? It's on a dashed line, and the dashed line does not include the solutions. It's just the boundary line for the solution set. Okay. Sketch the graph of the inequality. These are going to require a little bit more work. The easiest way to graph is to get this in slope-intercept form. So what should we do with this first inequality to get it in slope-intercept form? Subtract 5x on both sides. So 4y is less than or equal to -5x plus 12. And then divide everything. All three things must be divided by 4. So y is less than or equal to -5/4 x plus 3. To graph this, we start at 3 on the y-axis. Our slope is -5/4. That means, how do we move? Down 5, right 4. Down 5, you've used your negatives, so then right 4. Down 5, right 4. You could reverse your slope and go up 5, in which case you haven't used the negative, so then you'd have to go left 4 to use the negative. Before you draw in the line, think about, is the line part of the solution set or just a boundary for the solution set? It is part of the solutions because of the less than or equal to. So you might want to jot yourself a note. Less than or equal to means line is part of the solution set. So we draw a solid line, preferably with a straight edge. And then we have to think about where to shade. And some teachers in the past have told you shade up or shade down or shade up and right, or there's all different ways to describe what you're doing. One way to do this is to pick the point 0, 0 and plug it in and see if it makes a true statement. If 0, 0 makes a true statement, shade on that side of the line. If 0, 0 makes a false statement, shade on the other side of the line. But you want the shortcut? The true shortcut, put your pencil on your y-intercept. It says y is less than that line. Where on this graph are the y values less than where your pencil currently is? Under. So right here, our y value is 3. We want the y values to be less than what they are on this line. So that would be 2, 1, 0. That's down here. I don't want you to think so much about tricks or weird ways to remember it. I want you to think about what that symbol means. Y is the shaded stuff. The shaded stuff must be smaller than the boundary line. Where are the y values smaller than they are on the boundary line? All right, B. What do we need to do first? Subtract x on both sides. So negative y is less than negative x plus 2. How do we get rid of the negative? Divide by -1. Anyone remember anything crazy about inequalities and dividing by negatives? When you divide by a negative, see, using a highlighter makes it change slides. You have to switch the sign. So, oops, I want a pen. Y is greater than negative x divided by -1 would be positive x minus 2. We start at -2 on the y-axis. What's our slope? Up 1 over 1. Before you draw in the line, and this is what usually happens, I get in a rush, I draw the line in, and then I think, oh crap, is that supposed to be a solid line or a dashed line? And if it's supposed to be dashed, I have to take my eraser and go back and erase chunks of the line. So try to think of it before you draw the line in. Should this be a solid or dashed line? Dashed, because it's just greater than, which means that this boundary line is not part of the solutions. On the y-axis, my y value is -2. Where on this graph would my y value be bigger than -2? Straight up. So I shade here. How do you feel about graphing linear inequalities? Wow. Good, great, awesome, cool. There we go.